Hi guys, welcome to another section of Learning with Prep class. I am Tutor Chima. Now in today's video we are going to continue with what we've been doing. We've been solving past questions on WAEC Chemistry 2018 and today we'll be looking at questions 41 to 45 because in the last video we looked at questions 36 to 40. So for those of you that have been following our videos, how have you been seeing our videos? I believe it has been very helpful, it has been very engaging, entertaining. You've learned one or two tricks that have helped you to be able to tackle some of all these questions you've been seeing in chemistry, especially the calculation aspect. So always subscribe to our YouTube channel, like our videos, use our comment section for dropping one or two questions, and if you look below there you see a notification icon. I urge you to click it, and when you do, you'll be getting, or you'll be the first to be notified whenever we have an educational content like this. The notification icon will always act as a reminder. It will remind you whenever we have an educational content so that you just enter straight into our WhatsApp and tap into the glory of chemistry. Continue following us and feel free to share our videos so that it's going to reach as much viewers as possible. When you are now fond of our channel, I believe your prowess will improve in not only chemistry but in every other subject you find engaging in our channel. Alright guys, without wasting your time, let us go straight to the business of today, which is to solve past questions on WAEC Chemistry for the year 2018. Like I said, we're looking at questions 41 to 45. 41 says, what is the relative molecular mass of a compound which have an empirical formula of CH2O? What is the relative molecular mass of a compound which have an empirical formula of CH2O? This question is not that direct. It's kind of tricky because they just give us empirical formula, nothing more, nothing else, and they're asking us to find the molar mass of the compound. To solve this kind of question, we are going to base it on assumption. But we know empirical formula into bracket N equals molar mass of a compound. Empirical formula into bracket N, this N, which now represents what will now help you to determine, to make it a molecular formula. So empirical formula of a compound into bracket N equals molar mass of a compound. So what's the empirical formula? CH2O into bracket N equals molar mass of a compound. So from your CH2O, you have your C, carbon as 12, plus your hydrogen is 2 atoms, which is 2 times 1. That's 1 times 2, plus oxygen is 16, which is this, into bracket N equals molar mass of a compound. So 12 plus 2 times 1 is 2. And there have been an error here. I have made 1 or 2 mistakes because this is 12 plus hydrogen is 2 times 1. And that should get it's okay. Now this is 12 plus 2 times 1 is 2 plus 16. That's supposed to give us 18, but I wrote 16. Okay, that's the error there. So this is supposed to be 18. It's supposed to be 18. So if you are jotting this on your book, you can correct that. I'll try as much as possible to correct it in the PDF file. So that's 12 plus, this is 2 plus 16, so this is supposed to be 18. Because 2 plus 16 is 18. So 12 plus 18 will give us 30N. So 30N equals molar mass of a compound. 30N equals molar mass of a compound. So now, from the options given, only 180 is divisible by 30 to give 6. So look at the assumption here. We see that we will base all these things. Look at the question rather. We see that we base what we have here on our assumption, or yes. So I'm going to be assuming that the compound they are talking about here is glucose or maybe fructose. Now, out of all of them here, only 180 is divisible by 30 without having a remainder. All of them will give a remainder except 180. Now, if you divide 180 by 30, you will get 6. Now, this gives the molecular formula of the compound as C6H12O6, which is either glucose or fructose or any hexose sugar. So if you divide 180 from this option by 6, by 30, you get 6. And when you use 6 to multiply CH2O, you get C6H12O6. So the best choice there is 180. So our correct answer is 180. Like I said, that the question is somehow tricky. You have to base them on an assumption. So 180 will be the best answer. 42. Atoms are electrically neutral because they. Atoms are electrically neutral because they. Is it that they do not conduct electricity? Why are they neutral? Is it that they do not conduct electricity? Is it that they contain equal number of protons and electrons? Is it that they are composed of neutrons and electrons? Is it that they cannot be attracted by electromagnetic field? Why are atoms neutral? Now, for atoms to be neutral, the number of protons must be equal to the number of electrons. That's the only thing that will make an atom to be neutral. Why? Because protons are positively charged and electrons are negatively charged. So atoms are electrically neutral because they contain equal numbers of protons and electrons. That's the answer. Why? Protons are positively charged, electrons negatively charged. So if the protons are now equal to the electrons, the atom will become electrically neutral. So that's the answer. So the answer is that they contain equal number of protons and electrons. So the B is your best answer. 43. Common salt, NaCl, is used for preserving foods. Which of the following properties could be used to determine its purity? This should be its purity before use. Common salt, NaCl, is used for preserving foods. We use it to rub on meats, chicken, to preserve them from decay, fish. So when you rub salt on the fish, meat, also it prevents microbial attack, because any microbial or any microbe that attack that food stuff will become what? Dehydrated. It's going to become, it's going to lose water, and die off. So why? Now, they're asking us what we can use to test the purity of this common salt, NaCl. So which of the following properties could be used to determine its purity before use? Is it solubility in water? Is it melting point? Is it relative density? Is it crystalline nature? Now, you must know that for you to test the purity of any substance, or for any substance to be pure, it must have a stable boiling point and melting point. So I said a pure substance will have a specific melting point and boiling point. Now, the presence of impurities lowers the melting point of a substance and also increases the boiling point of the substance. Are you following? So for a substance to be pure, or for you to say any substance is pure, the boiling point must remain the same. So the boiling point of pure water is what? 100 degrees Celsius. The melting point of pure ice is 0 degrees Celsius. Anything less than that, it is not pure. Anything that makes water to boil higher than 100 degrees Celsius at normal atmospheric pressure, that simply means that water contains impurity. So impurity usually alters the melting point or boiling point of the substance. So for you to detect if a substance is pure, it must have a stable or specific melting point and boiling point. So in the options, we don't have boiling point, then we have melting point. So we'll go with melting point. So melting point is what we use to determine the purity of common salt. 44. Which of the following electrons configuration represent the transition element chromium? Which of the following electronic configuration represent the transition element chromium? Is it option A, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 4d4, 3d4? Is it option B, 1s2, 2s2, 2p6, 3s2, 3p6, 3d6? Is it option C, 1s2, 2s2, 2p6, 3s2, 4, 3d4, or 4s1? Is it option D, 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5? It can be confusing, but let us see. Now I said here, chromium has an atomic number of 24. The electronic configuration should be, so we are looking at 24. All these, we call it superscripts. All these superscripts should add up to 24. So 2 plus 2 is 4, plus 6, 10, plus 2, 12, plus 6, 18, 18, plus 4, 22, plus 2, 24. So the electronic configuration should be 1s2, 2s2, 2p6, remember that the p orbital, maximum of 6 electrons, s orbital, maximum of 2 electrons, d orbital, 10 electrons, okay? So 1s2, 2s2, 2p6, 3s2, 3p6. If you don't know this SPDF notation of bright electronic configuration, I bet you to go and know it, to go and learn it rather. This may not be the best way to start teaching that. So the normal electronic configuration should be 1s2, 2s2, 2p6, 3s2, 3p6, 3d4, 4s2. So although the 4s shell should come before the 3d shell, but for the transition metals like chromium, manganese, iron, the 4s is written before the 3d. So the 4s is written after the 3d, because during ionization electrons leave the 4s shell before the 3d shell. So we usually write this 4s shell last before the 3d shell for transition metals only, because during ionization, when the atom is going to the ionic state by donating electrons, electron will leave this s orbital before the d orbital. But the point here is that this will not be the electronic configuration of chromium, or this will not serve as a correct electronic configuration of chromium, because half-filled or completely filled d orbitals, this is this 3d now, half-filled or completely filled d orbitals are more stable than those with one electron less. Now, completely filled d orbital has maximum of 10 electrons. So half-filled, we have 5 electrons. So what I'm trying to say is that half-filled, which is 3d5, or completely filled, which is 3d4, which is 3d10 rather, half-filled, which is 3d5, or completely filled, which is 3d10, is much more stable than this 3d4. So half-filled or completely filled d orbitals are more stable than those with one electron less. You can see that this one, 3d4 is one electron less. For it to be half-filled, it will be 3d5. For it to be completely filled, it will be 3d10. Are you following what I'm trying to say? So 3d10 or 3d5 is much more stable than this 3d4. So because of that, electron will jump from this 4s1 to here to make this one 3d5. Are you following? So now I said that therefore electron will jump from the 4s orbital to a 3d, making a perfect electronic configuration to be 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, and 4s1, because electron will jump from this 4s2 to this 3d4 to make this one 3d5 and 4s1. So this will be the correct electronic configuration: 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, and 4s1. Which one has that? If you look at all of them, the one that is close to that is option D. Just that they wrote the 4s orbital before the 3d orbital. So 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, and 4s1. So just that they wrote the words. They wrote the 4s before the 3d5, but it's supposed to be the d orbital before the 4s for the transition metals. So I'll go with option D, irrespective that they wrote the 4s orbital or the s orbital before the 3d orbital. So this is the best option. 45. The atomic number of an isotope of hydrogen is equal to its mass number because the atomic number of an isotope of hydrogen is equal to its mass number because it has a totally filled valency shell, it has a high charge to mass ratio, it does not contain neutron, it exhibits isotopy. Now, the only thing that will make the atomic number of an element to be equal to its mass number is when the element does not have what? A neutron. Why? Atomic number is the number of protons. Mass number is the number of protons and neutrons. So mass number should be bigger than atomic number. Atomic number, number of protons only. Mass number, number of protons and neutrons. So for the mass number to be equal to the atomic number, it means that the mass number will not contain neutron. You get the point? So that simply means that mass number has only protons, just like the atomic number that has only protons. So the hydrogen isotope protium has a mass number 1 and atomic number 1. Why? Because it has no neutron. So the only thing that will make the mass number equal to the atomic number is when that substance or that atom has no neutron. So the answer is when it does not contain neutron, when it has no neutron. Alright guys, we've come to the end of today's section of Learning with Purpose, where we looked at past questions on WAEC chemistry for the year 2018. As you followed the video completely, you saw that we solved questions 41 to 45. We've dropped a link for you. Type this link on your browser. When you do so, it will take you straight to our WhatsApp group. Now, when you join us on our WhatsApp group, you'll be getting updates, you'll be getting infos on the latest content we have on our channels. See you in the next video. I still remain Tutochima. Bye.